This video explains how to build a robot tool to transport products. Download the 3D CAD file of the robot tool. The file name is gripper_2finger_version2.sldprt. Select the Modeling tab. Click Geometry in the Import group. Open the downloaded file. Select Collapsed of Feature Tree in the Import Model window to create single geometry. Select Collapsed of Organized Geometry to combine all meshes into a single geometry set. A geometry set is a collection of geometry contained in each geometry of the feature tree. When the total number of 3 triangular polygons, which generate a mesh, exceeds 10,000, a new geometry set is created. Set +Z to up axis. Click Import to import the 3D CAD data of the robot tool. Check the number of triangular polygons in the imported model by the following steps. Click Tools in the Geometry group and select Count Triangles of Simplify. Click Active Component in the Count Triangles window. The number of triangles is displayed in the Output window. Since total triangle count is 3,767, there are 3,767 triangles. If the number of triangles is large, unnecessary parts can be simplified. However, it is appropriate here, so use the triangles as they are. Click the robot tool to select the geometry. Right-click on it and select Tools and Explode to disassemble the geometry. Selecting the gripper arm in the -x-axis direction shows that the gripper arm is disassembled into one piece. Selecting the gripper arm in the +x-axis direction shows that the gripper arm and the drive stand are integrated. Thus, they need to be disassembled. Right-click on it and select Tools and Explode to disassemble the geometry again. Selecting the gripper arm in the +x-axis direction shows that the gripper arm is disassembled into one piece. To open or close the gripper arm, specify the desired position and configure the mechanism setting. With the gripper arm selected, right-click on it and select Extract and extract link. In the Component Graph window, a link named link_1 is newly created. With this link setting, the gripper arm can be operated separately from the drive stand. Select the gripper arm in the -x-axis direction. Right-click on it and select Extract and extract link. In the Component Graph window, a link named link_2 is newly created. Select link_1. In the Link Properties window, there is an item called Joint Type. You can select Fixed, Rotational, Translational Follower, or Custom. Fixed is selected by default. To move the gripper arm in the translational motion in the x-axis direction, select Translational. With Move in the Manipulation group selected, check the 3D world. There is a small arrow in the center. This arrow indicates the motion direction. Since the gripper arm is set to move in the +Z axis direction, change it to the +X axis direction. In the Link Properties window, change axis to +X. The motion direction in the 3D world is changed to the +X axis direction. Add a setting for controlling the gripper arm motion. In the Link Properties window, set controller to new servo controller. Servo controller is set. In the Component Graph window, servo controller is created under Behaviors. Select link_1 again. Set the maximum and minimum values for the movable range of the gripper arm. Set minimum limit to 0. For maximum limit, use the default value 180. Configure the mechanism setting for link_2. In the Component Graph window, select link_2. In the Link Properties window, set Joint Type to Translational Follower. Translational Follower follows the motion of the specified joint. Set Driver to the servo controller J1 so that link_2 follows the motion of link_1. Select Interact in the Manipulation group and move link_1, gripper arm, in the x-axis direction. You can see that link_2, gripper arm, follows the motion of link_1. Since link_2 moves in the plus z-axis direction, configure the settings so that link_2 moves in the minus x-axis direction. In the Link Properties window, change axis to -x. With Interact in the Manipulation group selected, move link_1, gripper arm, in the x-axis direction. You can see that link_2, gripper arm, follows the motion of link_1 in the minus x-axis direction. Delete unnecessary parts as follows. Select a small cylinder in the center of the robot tool. Press the Delete key, select Delete in the clipboard group, or right-click on the cylinder and select Delete to delete the cylinder. In the same way, select and delete other 3 cylinders. There is a long slender part between the 2 gripper arms, which are open. Select and delete it. Open the Home tab. Select Interact in the Manipulation group. Move the gripper arms to the desired endpoint. In J1 in the Component Properties window, the value of about 30 is displayed. The maximum movable range of the gripper arms is about 30. Set the maximum movable range of the gripper arms by the following steps. Reset the simulation. Select the Modeling tab. In the Component Graph window, select link_1. In the Link Properties window, set maximum limit to 30. With Interact in the Manipulation group selected, move the gripper arm. You can see that it moves to the position of the set maximum value. Select the Program tab and check if the checkbox of Stop at Limits in the Limits group is selected. If it is not selected, the motion will not stop even though the gripper arm exceeds the movable range. In this case, select the checkbox of Stop at Limit. Configure the material settings. In the Component Graph window, select gripper_2 finger_version 2. Click Tools in the Geometry group and select Assign of Material. In the Assign Material window, select the Library tab of Materials. To assign a brass material, select Brass and click the Drive stand of the robot tool. To assign a copper material, select Copper and click the gripper arms of the robot tool. Close the Assign Material window. Set the motion of the robot tool. In the Component Graph window, select gripper_2 finger_version 2. Click Wizards in the Extra group and select End Effector. End Effector automatically adds the control settings required for robot tool. There is an item called Controls in the End Effector window, where you can select the method to control the gripper arms. There are 4 options: None, I/O, External Axis, and I/O/External Axis. With None, motion is not set. With I/O, motion is performed with I/O signals. With External Axis, motion is performed with an external axis of the robot. With I/O/External Axis, motion is performed with I/O and external axis. Select I/O here. Select the signal type in Input Signals. With one action signal to open/close, one signal is used to perform open or close motion. When true is set, close motion is performed. When false is set, open motion is performed. With 2 separate signals to open/close, 2 signals are used. For the first signal, open motion is defined as true and no setting is defined as false. For the second signal, close motion is defined as true and no setting is defined as false. With 3 signals, both options above, 3 signals, which are explained above, are used. Select one action signal to open/close here. In J1: current state, define the current position. To define the current position with the gripper arms closed, reset the simulation and select Closed. In J1:IN_action_port, Set the port connected to the robot to the default value 100. In J1:out_open state_port, the state in which the gripper arms are open is output to the robot. Use the default value 101. In J1:out_closed state_port, the state in which the gripper arms are closed is output to the robot. Use the default value 102. With this setting, the open or closed state of the gripper arms can be sent to the robot. Click Apply. You can see that multiple items have been added to properties and behaviors in the component graph window. With EOAT_mount interface under behaviors, an interface for connection is defined. With tool container, a tool frame is stored. The tool frame specifies the center position of an object when it moves, like the gripper arm of the robot tool. With gripper logic, a Python script logic for opening and closing the gripper arms is set. Within _J1_action, out_J1_open state, and out_J1_closed state, I/O signals for opening and closing the gripper arms are set. Expand tool container in Tools. Select TCP to set the axis for opening and closing the gripper arms of the robot tool. Select Move in the manipulation group and place the frame between the gripper arms as follows. Drag the Z-axis arrow in the plus Z-axis direction, hold down the left mouse button, and press the Shift key. The mark to select the alignment position appears. Align the position with the indentation in the gripper arm and release the Shift key and the left mouse button. Set the axis for attaching the robot tool to the robot as follows. Under the root node in the feature tree in the component graph window, there is a frame named Mount Frame. This frame is an axis used to connect the robot and the robot tool. Use the default position of the axis here. In the component graph window, select EOAT_mount interface. In the Properties window, expand section:"robot tool." Expand hierarchy field:"hierarchy. Mount frame is set. Since the robot operates as a parent and the robot tool operates as a child, leave the checkbox of parent unselected. Expand tool export field:"TCP. Tool container is set. When the robot tool is connected to the robot, the setting is exported. This is the end of the explanation of how to build the robot tool to transport products. Thank you for watching.